So, Chapter 5, Association Analysis, Basic Concepts. So, this is the Unit 5 in your Introduction to Data Mining textbook. And this chapter mostly presents a methodology which is called association analysis. And this is mostly useful in discovering interesting relationships which is hidden in large data set where large amount of data are available. And in those data, large amount of data set available, we are going to analyze the data in such a way that we will be able to extract meaningful patterns and associations. And those associations will help user or human to again get into some meaningful um, implementation. So here comes the association rule mining. So what it is mostly. Uh, so if you are given a set of transactions and there you can find a set of rules, and those rules will mostly find out what are the occurrences of items those are involved in those transactions. Okay, and if you see, this is a table given to you. This is a transaction set in the table, and there are total 5 transactions: 1, 2, 3, 4, 5. And the item total set of items, if you see, bread, milk, diaper, beer, eggs, coke. So these are the different items available, and in each transaction there is an association, if you see. So bread, milk are bought together in first transaction. In second transaction, bread, diaper, beer, eggs are purchased or were involved in the transaction. So likewise, you have 5 transactions. So if you have a transaction set like this in a table format, this type of transaction is also called market basket transaction. And some of the association rules are in this way. Okay. So first, let me give you a brief overview. So this type of table, it will give an example of some data which is commonly known as market basket transaction. So here each row in this table will correspond to transaction, and which contains a unique identifier will be there, like TID, transaction ID, and set of items to be brought by a given customer. So sometimes if you take this into consideration in terms of any retail environment, so in that case, some of the retailers will be interested in analyzing the data from the transactions to learn about purchasing behavior of the customer. Okay, and that purchasing behavior will like the valuable information, it can be used to support a variety of business related application. So what are those applications again? Marketing, promotions, or how to manage the inventory. Okay, if let's say some person is buying milk and he is most likely to buy bread as well. So if there is the availability of milk, then the retailer will be interested in keeping the inventory proper, or there will be enough amount of data available for bread product also, or bread category also. So because of that, we need this. And in case of customer relationship management process also, this type of association rule mining concept is really helpful. So some of the uncovered relationships can be represented in the form of set of items presented in the transactions, and those can be called as frequent item set. So this is an important concept. Frequent item set means what? Set of items available in a set, okay, or collection of items available in a set which are likely to be frequently or likely to be included. Okay, or let's say bread or milk, this item set. So if someone buys milk, he's most likely to buy bread as well. So this becomes a frequent item set, and that frequent item set is also called as association rule, and association rule is written in this way. Association rule basically represent the relationship between two item sets So in the left hand side there is one item set, and right hand side there should be an item set, and every item set should be included in the curly braces the way it has been written. And each item set can contain single item, two items, or more than two items. It depends on the case to case. So for example, let's take this example: diaper tends to beer. It means what? So this rule suggests a relationship between the sale of diaper and beer, because many customers who buy diapers will also buy beer, and retailer can use this type of rules to help them identify new opportunities for cross selling their products to the customers. I hope you got some idea about what is the association rule mining. If you come to this one, okay, so this type of rule, it suggests a relationship between the sale of milk bread in one part and eggs coke in another part. So let's say some customer who buy milk and bread together will likely also buy eggs and coke together. Okay, and retailer can use this rules to help them identify their own perspectives. I mean, new opportunities for cross selling, or for of the products, or for their promotion purpose. If you have You can take the example of online platform. Let's say any online platform, maybe Amazon or Walmart, or let's say Instacart, which you use for grocery mostly. So if you are buying something, let's say you are finding for milk, right? So there you will see in the recommended or in the recommendation or recommend tab, you will see a similar type of element. It may be bread, maybe some fruit, maybe some vegetable. It depends. Okay, so they give you more options or recommendations so that you will buy more. This type of um, in that type of application, this association rule mining is really helpful. Now, moving over to association rule mining process. So there are two methods to find the frequent item set. So first, association rule mining means finding out the frequent item set which will occur frequently, likely to be occurring frequently. So for that process, there are two methods mostly, which is the first one is a priori, and then is FP growth or FP tree. So in the first days lecture, we will be covering the a priori method. So what happens actually? So using there are two methods for generation of frequent item set. So these are then used to generate these are mostly useful to generate the strong association rules from frequent item sets. And these rules must satisfy the minimum support. Here if you see min sub, minimum support, and minimum confidence, means CONF. So these are two different concepts that we must follow while generating frequent item sets or performing association rule mining. So what are these two concepts again? We will look into that. These are two most important part in association rule mining. Here see, I'll be giving you more examples as well, so don't get confused. Here item set. So what is an item set? So that is nothing but a set of or collection of one or more items. So if you are buying these three items together in this transaction, this becomes an item set and it will be enclosed within curly braces. Okay, so now K item set. K item set means what? If an item contains K number of items. Let's say there is an item set which only contain milk, not the bread and diaper. So in that case, it will become one item set. So this type of item set here, bread and milk. What is this? This means this item set contains two items, so that is why it becomes two item set. If the second one has four items, then it becomes four item set. It works that way. Next, there is one concept which is really important in association rule mining. It is the support count. It is also denoted by sigma. So what is support count? Actually, it depends on the occurrences of items or occurrences of an item set. So if there is a transaction or set of item sets involved in the transactions, then how many times or what is the frequency, how many times it is occurring in the item set, or what is the frequency of it. If we likely to find out milk, bread, diaper support count, then how to find out that? Look at this table. Go through each of the transactions one by one. So first one, does it contain milk, bread, diaper? We want all of these three together. No. Milk, bread, diaper? No. Milk, diaper, milk, bread, diaper? No. Bread, milk, diaper? Yes, there is one occurrence. And here also it contains one occurrence. So that is why in all of the five transactions, there are two occurrences of this item set, which is a 3 item set. Okay, so its support count is 2. Then comes support. Support count is different. Support is different. So support is actually a fraction of the transactions that contain an item set. So how to calculate this actually? If you are uh, find out, you're supposed to find out the support for this item set, milk, bread, diaper. And how to find out that? First, you need to consider how many times these 3 items all together appearing in the transaction, which we found out like 2 in the first step, that is support count. First you need to determine the support count 2, then it will be divided by how many total number of transactions are there, that is 2 divided by 5, that is your support. Then the frequent item set is, it is an item set whose support is greater than or equal to min sub threshold. So I was showing you this one, right? Min sub support. So this is again important in association rule mining or frequent item set determination. So frequent item set is something where the item set support. So let's say the support is 2 and the min sub threshold, this is a value to be assumed actually. Or let's say the min sub threshold you are setting up to 3, but the frequent item set support is 2. Then here the frequent item set support is not actually greater than, neither it is greater than nor equal to the min sub threshold 3. So that will not be considered as a frequent item set. Always an item set, in order to be considered as a frequent item set, its own support should be greater than or equal to the min sub threshold. That is the rule actually you need to remember. Let's see an example. Association rule. So an association rule can be written in this way, we have seen in the previous slide. So there is one implication expression of this form. So if x tends to y, that means x and y are item sets. So here for this one, um, so what are the item sets here? This is one item set, and here beer is another one item set. And there is one implication relationship in between them. This is the general form of writing an association rule. We are still using the same example. Here, support and confidence. We need to find out the support and confidence. Support we have seen. This is the formula. Fraction of transactions that contain both x and y together. Okay. So let's say first we are considering this association rule. Milk, diaper, beer. Okay, I cannot select it. Okay. So first we are considering this milk, diaper tends to beer. So how to find out the support count of these two item set? So two, that is, this one is one item set and beer is another one item set. But again, milk, diaper together can be called as k item set. Here k equal to 2, so it will be 2 item set. So how to find out the support count? So actually, what is the occurrence or the frequency count of milk, diaper, beer together? So in the last slide, we have determined how to find out it. That is 2 divided by total how many number of transactions, which is 5. So it comes as 0.4. Then there is confidence. So these are the two metrics we need to take into consideration for rule evaluation. So confidence actually is it will measure how often items in y, that is this is the y part, appear in transactions that contain x. Okay, so if you are having a transaction, any transaction where you have the appearance or frequency count of milk typer, so in that condition, how many times actually the Y or the beer is occurring there, that you need to determine. So how to find out that? So it should be confidence will be calculated in this way. So all of the three from both the sides X and Y, their own support count. So milk diaper beer, we found it out like two, right? Milk diaper beer. Okay, milk diaper beer, milk diaper beer. Two times it is occurring in the transaction if you see. So 2 divided by in the left hand side what you have here, that you need to decide. So frequency count of milk diaper. So how many times milk diaper occurring? Here it's not. Here also no. Yeah, here we found one milk diaper, milk diaper, milk diaper. So 3. So it will be 2 divided by 3. So this is how you will calculate the support and confidence of an association rule. Okay. Any question up to this point?
Yeah, why can't you count TDI3 since that also has milk, diaper, and beer?
Say again.
Oh, why can't you count TID3, the third one, since it also has milk, diaper, and beer?
For what you are asking me? Milk diaper. Are you asking about the support or the confidence?
The support.
The support. So milk, diaper, beer together, right? So how many times? Milk, beer, diaper, no. Milk, beer, diaper, no. Milk, beer, diaper, 1. Milk, diaper, beer, 1. Yeah, it's 2, right? You are saying why isn't it 3?
Oh, sorry, I was thinking of a different way it was solved. Never mind.
Yeah, it's written here actually if its support is determined in this way. So first, you will include both of the sides x. So let's say this is x, this is y. You include both of them together. So milk, diaper, beer. How many times it's occurring in the transaction? Milk, beer, diaper. Milk, beer, diaper 2 times. So that is why you are having 2 here divided by total number of transaction. But for confidence, the numerator is same, okay, but the denominator, it will be only the x part, milk, diaper together. So let me erase it. Milk, diaper, this is 1, this is 1, this is 1. So 3 times, that is why you are having 3.
Okay, thank you.
Okay, yeah. Okay, so now association rule mining task. Yeah, this one I have already explained, the min sub confidence, min sub support, and min confidence threshold. So for a given set of transaction T, we need to find out the rules which will be having this rule or setup, and confidence, sorry, support greater than equal to min sub, or confidence greater than equal to means up, and means min conf are the threshold. They will be assumed. Okay. And so these are the corresponding support confidence threshold. So sometimes a brute force approach for mining association rule is to compute the support and confidence of every possible rule. Sometimes for determining the association rule, you may follow the brute force approach, which is considered as expensive computationally, and there the I mean generation of rules for the time or the effort, it may increase exponentially. So you, in the last example, if you see there are only 5 transactions, so let's say you have and like 1,000 number of transaction or 10,000 number of transaction or a million number of transaction. In that case, always determining the uh, association rule, it can be computationally expensive. That is why it is called the brute force approach is considered computationally prohibitive. So that is why we are following different possible scenarios or different rules that I just have presented in the last slides, the so-called a priori and the FP growth or the FP tree. Now comes frequent item set generation. So this is for understanding that, let's say you have total D items. So 1, 2, 3, 4, 5. Okay. So there initially there is a null set. None of the frequent item set has been generated. So if you have 5 item set, how many total you can generate? That is given here. So it is actually 2 to the power D possible candidate item set. So for this case there are 5. So it will be 2 to the power 5 possible candidate item sets. So in between those possible candidate item sets, you will determine which one are the frequent and which one are not frequent. Okay. So total it will be actually, so in the given, in this picture, in this data set, it contains A, B, C, D, E, which can generate up to 2 to the power 5 because there are 5, 1, 2, 3, 4, 5 items. Minus 1 actually. So it will be 2 to the power 5 minus 1, and that will give you 32 including the null. Okay. So you have to also consider the null actually. And in some criteria, you can also discard the null also. Now next is brute force approach. What is brute force approach and why it is not advisable to follow this approach? So brute force approach for finding frequent item set is to determine the support count for every candidate item set in this structure. This structure is called lattice structure also. Lattice, because there are many lattice points. Okay. So A, B, C, D, E. So from A, including all the rest of the item sets. So how can you generate the candidates? Okay. So A can be combined together with B. So it can give rise to AB. It can make another combination AC, another AD or AE. Likewise, B can generate proper pairing or association with BC. We will not again make BA because AB is already present there. You got my point? So BC, BD, BE. Now next C will generate what? C will not generate CB because BC is already there. So CD, then CE, and then last DE will form DE. So something, if it's already formed, irrespective of their ordering, if it's already formed, we just have to discard that. Now, including the AB item set, so how many more candidates can be generated, including all other rest of the items? So the 3 item set combination can be ABC, ABD, ABE, ACD, likewise. Okay. Then, so this type of approach is actually what the brute force approach. You are kind of doing a manipulation, like manual manipulation. Okay. You are finding it manually. So likewise, in the next step, it will generate 4 item sets. Then the 5 item set, including all the 5 items. For given 5 set of items, if let's say D equal to 5, total possible combination will be 2 to the power D. So for n number of, let's say, so in that lattice structure, to do that candidate generation process, we need to compare each candidate against every transaction, and this operation is shown here in this picture. Okay, so here this is the transaction and this is the candidate item set. In the tree where from the item you are generating all the different candidates, 2 item set candidate set, 3 item set candidate set, 4 item set candidate set, or 5 item. So if the candidate is contained in a transaction, then its support count will be incremented. Okay. So for example, the support for bread milk is incremented 3 times because the item set is contained in the transaction 1, 4, 5. Each time it appears in a transaction, its support count will automatically increase. So this type, each time if you go through every transaction, such approach can be very expensive. Because why? Because it requires this many combinations, n into m into w. So total how many transaction multiplied by what is the width or the size of the transaction multiplied by size of the candidate set. Okay. So this is again expensive. And this is not advisable to follow that type of rule. Now, if you consider this example here, so rules originating from a same item set that can have, let's say milk diaper, milk beer diaper, so all of them has same support, but different confidence. Because of this, we may need to decouple or differentiate the support and confidence requirements. Okay. So all the rules are having binary partition on the same set. Okay. And like here you have 2 items, here you have 1 item. This same thing is going on for this one and this one as well. And in the next one, this side has 2 items and here there is another one. So this type of partition is called binary partition. But rules originating from the same item set. So if you see, we are only considering milk diaper beer, milk beer diaper. So in every transaction, we are using the 3 items, same 3 items, but different combinations. But still they are having same support but different confidence. Okay, that is why we need to decouple the support confidence requirement. So minding the association rule, it has 2 basic approach. First, frequent item set generation, where you see that all the item sets, whether they are support, are greater than or equal to the minimum support threshold or not. Then comes rule generation. So we need to emphasize on generation of high confidence rules, the association rules whose confidence values are more or high for each frequent item set. Okay. And always the frequent item generation process is computationally expensive. Okay, so frequent item set generation strategies. So there are 3 main approaches of reducing the computational complexity of frequent item set generation. So first you need to reduce the number of candidate item sets. Okay, M. So the next a priori principle that I'm going to explain you in the next slide, next section. So it is an effective way to eliminate some of the candidate item sets without counting their support values. Then another strategy is reducing the number of number of transactions. So if you reduce the number of transactions n, then as the size of the candidate item set increases, then a fewer number of or lesser number of transactions will be supported by the item set. Then comes reducing number of comparison. So instead of matching each candidate item set against every transaction, we can reduce the number of comparison. So how to reduce the number of candidates? Here comes the a priori principle. So what do we consider here? If an item set is frequent, if you find out that, then all of its subsets must also be frequent. Okay, how we will look into that? So for a given item set, let's say we have given 2 item sets. There is an item set X and Y. Okay. So if X is a subset of Y, let's say X is a part of Y or subset of Y, then support of Y can never exceed the support of X. That is the rule. This is what we follow in the a priori principle. And this type of property is also called the anti-monotone property. The rule that it explains here, this is also called anti-monotone. Now, there is a downward closure property of frequent patterns. So, if any subset of a frequent item set um, must be frequent. So let's say beer, diaper, nuts is frequent. So it's subset, a part of it. Let's say beer and diaper will also be frequent. That means what? Every transaction which will be having these three items, beer, diaper, nuts together, will also have beer and diaper as well. Okay. So the a priori and frequent pattern item growth are actually a priori was introduced on 1994. It's not that new. It is a old discovery. And same thing also goes with your frequent pattern growth as well. But they are really helpful and effective. So to illustrate the a priori principle, to illustrate that idea, so here this is a item set lattice, the same type of lattice structure. So suppose here, let's say after generating the candidate item set, suppose CDE is a frequent item set. Okay. So clearly any transaction that will contain CDE, if CDE are subset of any other candidate item set, where C, D, C, E, D, E, C, D, E, they contain C, D, E individually. Okay. So all of them contain that. So as a result, if CDE is frequent, then all subsets of CDE will also be frequent. Okay. So this whole part is considered as frequent and they will be considered for the candidate generation. But just in the reverse way, if an item set such as AB is infrequent, that means not frequent, then all of its supersets, AB superset is ABC, superset is ABD, superset is ABE. If AB is infrequent or not frequent, then all of its supersets will be infrequent and they will be pruned or discarded. Okay, and this type of strategy of trimming the exponential search space is based on support measure, which is called support based pruning. So here for a given item set, if a so if we are considering CDE, so it's all of its I mean CDE if it is a frequent item set, then all of its subsets smaller than it will be frequent. But in the conversely, in another way, if any of the subset is found infrequent, then its supersets will be infrequent and discarded. The whole part will be discarded. Now next comes the methodology. Okay, this is the basic approach of doing following the a priori algorithm. So first we will consider k equal to 1. So to go through, just looking at this, it is not easier to understand. You can refer this algorithm later. I'm going to show you the method actually, how a priori principle does the candidate generation. So let's say you have the transaction. We are using the same transaction. So first we are going to determine, we are going to just make another one table and include all the different types of items there. Then for each item, try to find out how many times the item is occurring in the transaction. So how many times bread is occurring? 1, 2, 3, 4. 4 is here. Coke, so 1, 2, 2 times. So like this, just write down all of their occurrences or the counts of how many times they're occurring in the transaction. And again, one thing, you need to determine the minimum support threshold, the min sub means confidence that I was telling you about. So means support will be considered as 3 here. So anything less than 3 will be discarded or pruned. So here, if you look at it, you will see which items support count or occurrence is less than 3, that is 2 and 1. So let me go to next step here. So here 2 and 1, they are to be discarded in the next step. So before that, I'm going to show you something. Here see, before pruning, so if every subset is considered, so this is a one item set, correct? So like this, we can make 2 item set, 3 item set also from this whole transaction. So in each step, what is the combination of items to be generated? Okay. So total possible one item set, including the 6 items, the combination will be 6. Then total possible 2 item sets for the given 6 items will be combinations will be 15. Likewise, total possible 3 item set for this given 6 items will be 20. So altogether 40 um, candidates will be there. But when you follow this process a priori principle, the the value decreases to 16 actually. How we are going to see that? And this is how it is effective. Only 16 candidate generation are performed. So as you decide, Coke and X have minimum support count, which is less than 3. So what are we supposed to do? We are going to discard them in the next step. And from there, we will make 2 item set. So bread with milk, bread with beer, bread with diaper. We are not considering Coke and eggs because they are discarded because their support is less than 3. Likewise, all the 2 candidate sets are generated, pairs or 2 item set. And we don't need to generate the candidates involving the Coke and eggs. So here now in this part, you also again have to determine bread milk for each 2 pairs, each combination, how many times they are occurring in the transaction actually. So if you see the table, this table, the first table, okay. In this table, you have to find out what are the occurrences of bread milk, then the beer bread, bread diaper, beer milk, diaper milk, beer diaper. If you compare, you will get this many number of counts. Do you have any question up to this point?
Um,
Is
how
this
does 6C2 equal 15? Oh,
6C2?
down there. Yeah.
Actually, it's combination. If you have 2 items, okay, so how many possible candidates will be there? So it is just considered in that way. So, yeah. So, okay, where am I? So, beer bread, bread milk. Okay, you got this point. How we are getting this support counts of each of the combinations? You just have to compare it with the first table. So now, what support counts you have for each pair? There you have to compare it with the minimum support 3. Okay. So here the 2 times you have to for this candidate set. So these 2 will be pruned in the next step. So after they are pruned, now next you have to decide the 3 item sets, 3 candidate item sets. So here you have 3 candidate item set. Now, if you again consider those 3 candidate item sets for each set, compare with the first table, initial table, and find out the support count. Okay. So there, uh, bread, beer, milk will be discarded because it is 1. But as all of them has the same support count, all of them are less than 3. So but still we need something, right? So from this 3 item set or triplets, we need to consider one. So which one we have to consider? If you see, beer diaper. Uh, so some of these from this combination, beer diaper milk and beer bread diaper, either their one item set or two item sets are already been discarded. So you just have to keep the remaining one whose combination or a part or a subset or a combination of it is not discarded in any of the previous step. So here we are just considering this one. Okay, so I'm going to show you one example here based on the same scenario that I was showing in the explaining the previous slide. Let's say you have a database, a transaction set in this way. TID and these are the items. Support count is considered 2. So first scan the candidate item set. One item set you will do. So find out their individual support counts. Then next find out which one is minimum and discard that. So D is having 1. So that will be discarded from this set. Yes, and we will keep all others. So in the next step, we are just going to prune D and keep all those which are available. Then from here, we will generate the two item set combination. Then for each combination, we will find the support count. Then find out which are less than the minimum support count 2. Discard them. Then keep those which are whose support are greater than or equal to the minimum support count 2. From here, generate the 3 candidate item set. Okay. So actually, if you see here, there the combinations will be AB, ABC, ABE, ACE, and BCE. Okay, so these will be the possible combinations. But ABC will be discarded because some here in the previous step we have discarded AB, which is a subset of ABC. Okay, because of that we will not consider ABC. Then we have, let me write it here. In that case, it will be easier to understand. So ABC. So I'm just considering the 3 item set from this part. ABC, then ABE, ACE, then BCE. Correct? So if we have all these 4 combinations, why are we only considering the BCE? Because for ABC, this will be discarded as in the previous step, the AB, which is a part of ABC, is discarded. Okay. For ABE, again, part of it is discarded in first step. So that is why this won't be included. Then ACE. So if you see ACE, AE, okay, that is discarded in here. So this part will be discarded as well, and you will just keep BCE in the next. And then this is our possible candidate item set that we got from our given database table or the transaction table. So BCE is the most probable combination which will be used in all of the scenarios. Now, for implementing the a priori, so we basically do the self join operation in all the steps. Then after joining, based on the minimum support count, we do the pruning. That is the basic step for generation of candidates. So an example here, if L3 is a candidate, is an item set having all these combinations, possible combinations or items. So if you join L3 to L3, then in the combination that is ABCD, which can be generated from ABC and ABD, and ACDE can be generated from ACD and ACE. These are the two possible combinations. So ACDE can be removed because here why it will be removed, because it's subset that the combination ADE is not in the item set here, which is not a part of this. That is why this AB, sorry, this ABCD, this ACE, this ABD, this ACE, this ABD, this ACE, this ABD, this ACD, this ABD, this ACE, this ABD, this ACE, this ABD, this ACD, this ABD, this ACE, this ABD, this ACD, this ABD, this ACE, this ABD, this ACE, this ABD, this ACD, this ABD, this ACE, this ABD, this ACD, this ABD, this ACE, this ABD, this ACD, 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 this AB This ABCD will be considered for the possible final candidate item set. Now, whatever process we have followed, so based on that, this is the algorithm, and using this, a program also could be written for this a priori algorithm. First, you are generating the candidate item set of size k. Size k can vary, and LK frequent item set. So in each step, you are keeping the frequent item set, that is L1. Then for every step, you are generating the candidate item set. For each transaction, you are going to count the number of candidates each time, how many times they are occurring in the transaction, and also comparing with the minimum support count. So this is the basic process. You can also refer the algorithm steps in your book as well. So this with this we are concluding the a priori algorithm.